Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, I'm going to explain you how to generate a staircase waveform using DAC. In the previous video, I have generated the square wave and the rectangular wave, and in this video, I'll show you how to generate the staircase wave. Yeah, so this is your DAC. For the DAC, again, we have to provide the proper binary inputs. So proper binary inputs we have to give it, and it is possible to generate the staircase wave. So to generate the staircase wave, so let us assume this is my, I'll consider two different levels. Let us consider this is my 255. I'm assuming I'm using 8-bit DAC and this is my 00. So what I will do is I'm going to divide, or I'm going to assign different values like this. The first I will generate I need to generate like this. I want to generate output like this. Okay. So this is what my expected output here is. I want to generate the staircase waveform. To generate this, I have to give a different analog inputs for a different time intervals. So let us assume this is my 00, and then this is my first step. I'll assign 0 to the DAC, and in the second step I will assign something called 64. How many steps you want? Those many steps you have to divide it. I want 1, 2, 3, 4 steps I want to generate. So that's why I'll be dividing 255 divided by 4. When I divide, I'll get 64. So you have to generate each step with a 64 value. So this is my 0, then first step will be 64, second step will be 128, and third step will be around 192, and then finally 256. Like this, we have to assign different values to the DAC. According to that, DAC will produce for every one value, DAC will produce one waveform. Initially it will be 0. When you provide first value, that respective voltage it is going to generated by the DAC. During the second step, we have to assign some second value, that is 128. It will generate approx. According to 128, your DAC will produce the voltage for that, then similar to that 192, then finally for 256. And after that, if you want to do the same thing in a reverse order, that also you can do, or else you can directly come back to 0. So this is how you can generate the staircase waveform using DAC. So this is the theory, or this is the calculation behind your staircase wave generation using DAC. Let us go back to the code and see how we can implement the staircase waveform generation. If you look into the code, it is similar code what we have done in the previous video. There is no difference, but there is a difference only in the value assignment. Logic, everything is same, but only the thing is we have changed the different values to generate a different step. Okay, so according to the theory what I have explained, initially I'll be assigning DAC input with a 0, and I'll be assigning to the DAC control register. This is my first step. I'll assign with 0, and you can give some delay here. This is to generate 0. So this block what you're seeing, this is for 0, 0x00. And for the second step, I told you already, I'm going to divide totally 255 or 256 divided by 4 steps. That is going to create 64. So this is for first step, that is 64, and this is for third step, 128, and this is for fourth step, and this is a 192, and finally this is for last step, 255 or 256. You can give any one value. So here I have given 255. So like this, you can give different values to the DAC. According to that, your DAC will generate a different output voltage. For initially it will be 0 like this. Let us assume this is 0, and for the first step it will generate one value. For the second step it will generate like this. For the third step it will generate like this, and for fourth step it will generate like this. Okay, so when you consider like so it is going to be like this. So this is my, so this will be your first step, then like this it is going to be, and then finally like this. Okay, so in this way you can able to generate the staircase waveform using a DAC. So in case of staircase wave generation, again we have to give different digital inputs according to your requirement, what type of control signals or control value you want to generate as an analog output. I hope you are clear with this logic. Again, let us come back to the, yeah, here you can say this is your analog output configuration, AOut configuration. I have already explained in the previous video, just you can refer that one. So let us compile this and let us check the output. So this is your, as you know that already, this is your output window, or you can say debug window, and here is a logic analyzer. And if you want to make it a little bit, you can drag it up and just you can allow to run here. Yeah, you can see here. And also you can observe here output voltage, how it is changing. 0, then 1.8, then 2.4, something 3.2. So like this, it is able to generate. So even though they are different waveforms, these waveforms are nothing but analog outputs we will be using to control some of the functionalities in our embedded system. Don't think like these are all just experimental outputs. These control signals, these analog output, what you're seeing on the screen, these things we are going to use to control some of the functionalities of our embedded applications. Okay. So I hope you are clear with this video. So if you have any doubts or questions, please write a comment to us, or we can write your questions in the comment section, or else you can also mail us. I will provide the mail ID in the description box as well. Okay, I hope you are clear with this. So with this, I just want to end this video. So please subscribe my channel and keep on watching my YouTube channel, Know About Embedded System.